Hello, good morning all. Welcome back to learn the data structures. And today we are going to learn the threaded binary search tree. Uh, and we will implement the operations of creating a threaded binary search tree using the binary search tree logic only. And we'll display this threaded binary search tree by using threads. So we'll follow right pointer and right threads to display this threaded binary search tree. So here we will avoid the display by a recursive function which uses implicit stack and iterative function of display like pre-order, in-order, post-order, which uses a stack created by user explicitly. So here we are avoiding recursive as well as iterative functions, and we are using threads to access the right nodes or the in order successor nodes of the threaded binary search tree. So that is the basic application of threaded binary search tree, that we can use threads to refer in order predecessors or successors. So to display in order traversal of threaded binary search tree, we are basically going to use right pointers and right threads. So in this program, the threaded binary search tree we are creating is a full threaded binary search tree. So it consists of both threads, left thread as well as right thread. But for display of TBST, we are only going to traverse right thread. So let us start with the program. So here is the title of the program, and after this title, we will write class for TBT node. So let us start with header files. So these are the header files we have. So these are header files for a C++ program. And then after these header files, we'll add a class for TBT node. So this is the class for TBT node, and this class consists of, as you can see, we have a class name which is a TBT node. We have a public section. In this public section, we have a data part which is integer. Then we have two pointers, left pointer and right pointer. And then we have two threads which are Boolean values. So either they will be true or false. That is the left thread and right thread. And at the end of the class, we are creating a pointer for holding the address of root node of the tree. Okay, so this is the node structure for TBT node, or the node of threaded binary search tree. Now after this, we'll create a class for operations. So this class for operations will have three operations. So first operation is creation of TBT. Second operation will be finding the leftmost node, which is required in case of in order traversal by using threads. So see, now we have this class for TBT operation. So class name is TBT operation. We have this data member which is from TBT node. So we can access the nodes of TBT from this class, okay, in the TBT operation class here. Okay, so we will create nodes, we'll insert nodes, okay, as well as we traverse using threads. Okay, so in the public part you can see we have a function for inserting nodes in the TBT. Then this function has root as a parameter and new node. So root is for traversing in the tree, and new node is for inserting the new nodes into the tree. Now this second function is about finding the leftmost node. Now this function will be used for finding a leftmost of any node in the TBT. So we'll see that the logic of this function. And this third function is about threaded in order traversal. So we are going to use right threads for accessing the in order successor nodes, and then we'll display the in order traversal. So that is why it is called as threaded in order traversal. So this is the end of class. Here we have three functions inside the class. And then after this, we have the first function, which is insert nodes. But before going for insert nodes, what will we do? We will write main function first. So here is our main function, which will have some initial declarations. So see, this is our main function. So inside this main function, we have initially the title for threaded binary search tree, as this is the program of this TBT. Now we are declaring a new node pointer. Then we are declaring integer variables I, nodes and flag. And then we have initially root is equal to null, which we are going to pass to initially creation of the TBT. So if root is null, we will assign new node to root. And then we have this object of TBT operation class. So this object will be used for calling the member functions of this class. And after this, we'll have the first calling of the function, that is for creation. So here we'll say, we'll give a message for first operation, and that message is create threaded binary search tree. So this message will be like indicating that the further code is about creating or inserting new nodes into the TBST. So we are asking for how many nodes to add into the TBT. And after that, what we'll do? We'll start a loop. This loop will add this number of nodes. So see, we have this loop which will create a new node and will add into the tree. So see, this for loop is having a loop from 0 to less than nodes. So this loop will be repeated for number of nodes into the binary search tree. So we have this, initially we are allocating memory for TBT node, then we are accepting data to insert inside a node. So a new node arrow data will be assigned. Then we are initializing left equal to null and right equal to null initially. Similarly, we are initializing the threads which are L thread and R thread equal to false. Okay, so these are initial setup for a new node. Allocate memory, assign data, and then initialize left right to null, L thread R thread to false. And then we are asking for if root is equal to null. So we have initially set root equal to null here, right? You can see this. So initially, if the root is equal to null, what we'll say? We'll assign this first node created as a root. So this first node will be assigned as a root. And if we are creating second node or third node, so for that this if will be false because it will be created in the first node only. So for other nodes which are created inside this loop will follow else part. So in the else part, what we are doing? We are calling insert node function having parameters root. So the root created inside if is passed here, and then we are calling it with the second parameter, that is new node. So we are passing root and new node to this insert function. Now let us see the logic for insert function. So see, we'll now define insert function here, which is called inside main. So here we will define insert function. So this insert function is going to accept root and new node as parameters. So this is the definition of the member function outside the class. So this is the initial definition. See, so we have insert nodes function, and we have these formal parameters which is accepting root, and this parameter accepting new node which is passed from the main function. So main function has passed two pointers, and these are cached inside this root and new node. So we are going to use this root and new node to insert inside a TBST or threaded binary search tree. So we'll use this flag to indicate that if the flag is 0, the node is not inserted. So until the flag is not equal to 1, we'll keep finding the right place for the new node to insert into the TBST. So See, until the flag is not equal to 1. So for each new node, this flag will be initially 0 and we'll raise it to 1 when we successfully insert new node inside a TBST. So see, what is our logic for TBST? It is similar to binary search tree. So we are inserting if new node's data is smaller than root arrow data. So we'll go to insert into the left subtree. So this left subtree will check for whether left is equal to null, right? So we'll check for whether left is equal to null. So this is it. See, if the new node's data is smaller than root arrow data, we'll check whether this root arrow left is equal to null or root arrow L thread is equal to true. So if the roots left is equal to null or roots L thread is equal to true, that means that pointer root arrow left is used for thread, not for the child node. So if L thread is true, the left pointer is either equal to null or it is used for storing the address of its in-order predecessor. So in that case, you can add that child by replacing null value or a thread value. So how we'll attach? We'll attach it like this. So new node arrow left will have the value from root arrow left. New node arrow L thread will be initialized to root arrow L thread. Root arrow left will have a child node which is new node, and root arrow L thread will be equal to false as we have attached a child node now. So it is not going to be used as thread. As well as we have attached new node as a left child, so its in order successor will be its parent node, that is root node. So we will assign new node arrow right equal to root, that is parent, and as we have assigned this thread, we will say new node arrow r thread equal to true. Okay, so this is how we insert new node which as a left child in case of threaded binary search tree. So it is little having more steps because of the thread manipulations. So when we attach new node as a left child of the parent node, what we have to do? We have to initially copy the left and left thread inside the new node from parent node. So parent's left will be copied inside new node's left. Parent's L thread will be copied into new node's L thread. And then we attach new node as a left child of the parent. And then parent's L thread will be false as it has a child now. Again, as the new node is attached as a left child, so its parent will be its in order successor. So new node's right will be parent, address of parent root, and then new node arrow r thread is equal to true as it is being used as a thread to point in order successor node. Okay. Now after this we have successfully inserted new node. So raise the flag. So flag will be 1. Okay. So this is how we use flag when the node is inserted successfully. Now after this, if this root arrow left is not equal to null, then what is the case? So if root arrow left is not equal to null, what we say? Shift root to its left. So this is how we shift root to its left. So we'll say else root equal to root arrow left, and then we'll close this if here. So what this if says? If new node's data is less than root arrow data. So we'll do this for left subtree, right? And if this if the left is equal to null, and this else if the left is not equal to null. So we shift root to its left. Now after this, what we want, if the new node's data is greater than root arrow data. So what we'll do if the root arrow data is greater than, so for that we have this logic. So we'll have this logic here. So this. So if the new node's data is greater than root arrow data, so we'll check again if root arrow right is equal to null or root arrow r thread equal to true. Then we'll do this setup again as we have done for the left child. Now we'll do for the right child. So the right child, which is a new node, will copy the right pointer from its parent node as well as r thread from the parent node. And then we'll attach that new node as a right child. So root arrow right equal to new node, root arrow r thread equal to false. And then as this is the right child, so its parent will be its in order predecessor. So what we'll do, we'll say new nodes left equal to parent address, that is root, and new node arrow L thread equal to true, and then we'll raise the flag to 1. Now if root is root arrow right is not equal to null, so what we'll do, we shift root to the root's right. So this is how it happens for the right child. And then what we will do, we will close these brackets of for loop and function. So after this, we'll have a closing for loop and which is a while loop, and then closing for the function. So here you can see we have a while loop which will continue until the flag is 0. But when we insert node successfully, we set flag equal to 1, either a left child or right child. See. So we will insert the flag equal to 1. And then this while loop will break and then will stop. So this is how this insert node function works. And after this, we'll have the leftmost function. So the leftmost function will find the leftmost node of any given node. So this is the function for finding leftmost node. So we have TBT operation leftmost, and we have this address of a node. So we check whether that node is equal to null. If the node is equal to null, we return null value. Otherwise, what we will say, if node arrow left is not equal to null or its L thread is false, because if its L thread is there, we cannot traverse to back to parent. So its left should be null, okay, not equal to null, and L thread should be false. Then we can traverse to its left node. So we'll keep traversing to nodes left until nodes left is not equal to null or nodes L thread is equal to false. And then we return that leftmost node from the function. Now, this function leftmost is actually used inside the threaded in-order traversal. So we need this function in the threaded in-order traversal to find out the leftmost node. So let us see that function. So here we have that function. See, so here we have this function which is threaded in-order traversal, which has this root as a parameter. And now we are doing actually traversals using the thread, a right thread. Okay, so see, this is the function we have here, and then this is the current pointer, which is a temporary pointer, which will initially copy the leftmost address of root. So we will pass root to the leftmost function. So what it will return? It will return the leftmost node of root, and that is inside a current node. So we'll go to the leftmost node, and that is the first node to display in order. Okay, so this will clear in output also. So let us go ahead and see the further code. So in the further code, we have this part. So what is this? While current is not equal to null. So what we'll say? While current is not equal to null, display current arrow data. So we'll display current arrow data, and then we check if current arrow R thread is true. So current arrow R thread is true, that means it has a in order successor node. So if it is true, go to that in order successor and display it. So we'll say current equal to current arrow right. But if the current arrow R thread is not equal to true, that means we have to check the other condition. What is the other condition? What we will do? We will say else find out the leftmost of current node's right child. Okay, so either there are two cases. We have a node having right thread true. That means we can directly travel to in-order successor by current equal to current arrow right. But if the current arrow R thread is not true, that means that node has a right child. So if that node has a right child, so what we will do? We'll find out the node's right child's leftmost node, and then that is the current node. So this is how we'll find out the current node, and then we'll repeat this. What we'll repeat? We repeat this process of finding or displaying the in-order traversal. So this is the function for in-order traversal by following either right pointer or right thread. So I hope you understood this. Now we have written functions, okay, for in-order traversal. Now we'll call them inside main function. So this is the main function. You can see here we have these local variables, root equal to null, object of the class t1, and then we are asking for how many nodes, and then we are creating those nodes, right? And then if root is null, we are assigning root equal to new node. Otherwise, we are calling insert function for new node, okay, which will insert and then set the threads for each new node. Now, after this, what we will do? We'll call the in order threaded function. So that is this. So this is the second operation. So this is how we mention it. B threaded in order traversal, and then we'll call the function. So this is the function for threaded in order traversal, and we are passing root to that function. Now, after this, what we'll do? We return 0 and close the main function. Okay, so we'll return 0 and close the main function. Okay, so this is return 0 and close main. Okay, now see, we have written only two functions: creation of TBT, insertion of new nodes, and then traversing TBST by using right threads. So it's a threaded in order traversal, and we have called those functions inside main. Okay, so that's it for TBST. Now we'll run the program and let us see what output is there. So see, we have output here, threaded binary search tree, and see, we have displayed this first operation, create. So we'll ask, it is asking for how many nodes to add in TBST, right? So what I will say I want to add 7 nodes. Okay. So it is asking for enter data for new node. So my first node, which is the root node, is 10. Then the left child of root node is 5. Now, to the 5's left, I want 2 as the left child of 5. Then the right child of 5 will be 8. Now, after this, we want the right child of root node, that is 10, is 20. And the left child, here there is some problem here. No problem. Okay, so the right child of 10 is 20, and then the 20's left will be 15, and 20's right will be, I want it as maybe, okay, so we'll like this. Okay, so we have this here. Okay, so this is it. Okay, so we have this. Okay, so see, we have 7 nodes, and this is first node is 10. Now second node is 5, which is the left of 10. Now 2 is the left of 5, 8 is the right of 5, 15 is the right of 10, 12 is the left of 15, and 20 is the right of 15. So this is the input given. Now we'll display this input like this. So we'll have this display of in order traversal. So here we'll display this. So see, this is the in order traversal, threaded in order traversal, right? So see, 2 is the left of 5, 8 is the right of 5, Then we have a root node that is 10. On the 10's right, we have 12. And then 12's parent node is 15 and 15's right is 20. Okay, so this is the output for threaded in-order traversal. Okay, so this is for one uh, like test case. You can also run it for various test cases. So I hope you have understood the program. So I repeat the initial setup. So we have these header files, then we'll have this class for TBT node, then we'll have this class for TBT operations, then we'll have insert node function, okay, where we insert to the left or right, okay, and then we have this leftmost function, and after leftmost function we'll have a threaded in order traverse, okay. So that is it, and then we are calling these functions inside main. So this is how we call insert function here. If root equal to null, create root, otherwise call insert function. And then after insertions, we are displaying this tree by threaded in order traversal using right threads. Okay. So I hope this is clear. So I'll stop now. Happy learning data structures. Bye bye.